Thank you, Asri. Good evening to everyone. I know people are still coming into the team, so it's okay. We'll just let them in. So this is just a bit of background. This is actually a PG preview. So I'm as the program director for the MSc postgraduate programs in Heriot-Watt EPS. So I'm just going to share a bit about this topic, and then towards the end I'm going to share more about the program itself. So this will hopefully give you a bit of a flavor of what we do in our classrooms, even though it's online. So we are all back to face now, but at least you have some ideas of the topics or the knowledge that we impart on these courses and these programs. Shall we begin?
Yes.
Okay, so I'm going to start with a quick poll or quick question. What got you interested into this topic in the first place? So you will see a word cloud comes up. So let me just write it, the question. So just give a response in 1 or 2 words. When you think of this, when you see this title, what comes to your mind? And then I have a gauge of what people are expecting from this session. In the meantime, you all can see my slides, yeah?
Yes,
it's still on, yeah?
Yes.
Okay, so in the meantime, I'll just start because the first page is just a bit of introduction about myself. So, oops, I've lost it. So I'm Adlansyah Rahman. I'm an associate professor at the School of Engineering and Physical Sciences. So this is what I said just now, EPS. And I'm also in charge of the MSc programs. So we have 2 MSc programs, Renewable Energy Engineering and Advanced Mechanical Engineering. So a bit of my interest or my research areas is mainly bioenergy, but I've been dabbling into all kinds of renewables. I've been doing renewable energy since 2001, so over 22 years now. And also in energy efficiency, community work, and so on. So I'm the community member of the Energy Institute Malaysia branch. So Energy Institute is a UK professional body, and this is related to our program here. And also a committee on the National RPOS, so that's Academic Research on Palm Oil Sustainability Network. Also helping out in the Malaysian Palm Oil Certification Council. So if you know about MSPO, Malaysia Sustainable Palm Oil, so this is the work that we do. And advising on some startups. You can see Hygiene Energy, Biosekita, and Allo Energy. These are all actually working with communities. So these are mainly bioenergy works and working with communities. A bit about Heriot-Watt University. So we are from the UK. We are over 200 years old. We are the first mechanics institute probably in Europe and maybe the world in 1821. And over the years, we have become a global university with international campuses in Dubai and Malaysia. For Malaysia, we've been here, we had our 10-year anniversary last year. So we've been here since 2012. The campus that you see, our beautiful campus by the Putrajaya Lake, officially started in 2014. So these are just very brief facts. I'm sure if you want to find out more, do check the website and you can contact our team. If you want to arrange a visit to our beautiful campus, you can contact our team. So you have the Heriot-Watt UK, Heriot-Watt Dubai, and also Heriot-Watt Malaysia. And we actually operate as a global university, meaning that the programs are delivered globally. So UK, Malaysia, and Dubai actually deliver the same program at the same time. Students are doing the same assessments. And so in Malaysia itself, there's more schools in Edinburgh, and there's some specialist schools in Dubai. But in Malaysia, we have these 5 schools, and I'm parked at the EPS. Let me turn on the pointer. Where is it? Okay, here. So under EPS, we have chemical engineering, mechanical engineering, and electrical and electronic engineering. Civil engineering is parked under EGIS. Yeah, but these are the 4 engineering departments that we have. I myself is under mechanical engineering. So the programs offered by EPS. So we have the Masters of Engineering, MEng, in the 3 chemical, mechanical, electrical, and electronics. And then we also have the PhD. But today we're going to talk about the 2 MSCs, which is the Renewable Energy Engineering and Advanced Mechanical Engineering. Okay, let me see what have you got in the word cloud here. So I see the main one is energy. Some people talk about free environment, future of the world, green energy. So energy is a recurring, low cost renewable energy. And then there's some on climate change and carbon. So I guess because the title itself has the word energy, so energy becomes the main one. But there's also sustainable, there's also energy transition, and there's also net zero. So when I opened this, when I started this topic, really there's a lot of jargons, there's a lot of words being thrown about. Yeah, and I can see some of it in your responses as well. And I think this is important that we know what we are talking about. We've been looking at this for, I would say, in Malaysia, probably in the last 30 years. Yeah, but outside, maybe even longer than that. And there's a lot of terms going around. So these 3 ones, I think is the major one: sustainable energy, energy transition, and of course, net zero. So the talk itself is going to go over these 3 terms. If you have any questions, if you want to chip in, feel free to do so. You can raise your hand or you can write something in the chat, and either myself or one of my colleagues will flag me. So don't make it too rigid. Yeah, I think I can stop the poll now, and we can continue with the slide. So being an engineer, we always talk about problems. It's like there's not enough problems in the world. But I guess if you're coming from an engineering background or engineering degree, you know this. So engineers are here to solve problems. So the first thing that you need to know is what is the problem. So this is what we're going to look at. So energy itself being the main one. So you agree with me? Energy here, this map shows the world's energy problem. So you can see actually there's a disparity. And there's a few, my pointer is still here, yeah. So there's a few regions or the few reasons why we have this kind of disparity. If you look at far north and far south, one, they are developed countries, and 2, they actually require a lot of energy to heat up. They are very cold places. And then you have one in the middle here where they are also quite well developed now, and they need a lot of energy for cooling. And then the rest lies somewhere in between. So you see the less developed countries tends to use less energy. And then the more developed countries tend to use more energy. So there's a disparity here. The two main ones is we still use a lot of energy from fossil fuel. The latest numbers from IPCC, the International or Intergovernmental Panel on Climate Change, said that 83%. Yeah. So we are trying to reduce this, but we are still far away. We are still banking a lot on fossil fuels. And at the same time, this energy disparity means that still hundreds of millions lack access. And again, the latest numbers is over 650 million people is still what we call in energy poverty. Yeah. This is point in the early 2000s. I think it was around the same time, 2001, 2002. It was actually popularized by the Energy Institute. And then it has been taken up by UN and the rest of the world. When you talk about energy, you can't run away from this, what we call the energy trilemma. Yeah, so we have to balance between security, equity, and the environment. If you have the right balance, then you can say you have growth. Of course, these are all opposing. So they are the opposing points of the triangle. So if you want to focus on one, you will always take away from the other two. So this is the heartbeat, the balancing act. The link is there, so you can check. So there's also a list of all the countries in the world, especially under UN. Those countries are recognized by the UN. Where do they stand in terms of the energy trilemma? So you can check here. In Malaysia itself, we are not very big. Our consumption is still very small. But we are always still pushing towards both security and equity. Environment is not bad, but it's being pulled away by these two. So let's look at equity. What do you mean by equity? Okay, I see a question here from Omar. Yeah, so it really as an MSc program, so he's asking if you have a bachelor in chemical engineering, when you go into a MSc, this is where you upskill or you specialize. So you will see that renewable energy is very much related. It is still engineering. We offer the engineering course. So it is a progression from your engineering degree. And it should fall then in line with your interest. And I'm guessing your interest is renewable because you joined this talk. So I hope that answers your question. Let's come back to this. So equity really means the access to energy. So this is, you can see this number is from 2020. The latest figures, this has dropped. It's closer to 650 something, 657 million, if I'm not mistaken. So over the years, more and more people have access to electricity, which is good, which is what we want to do. But what it means then, the demand actually going to grow bigger and bigger and bigger. So here I can share a bit, and I don't know if you are not from Malaysia, we might not be familiar with the palm oil industry, but we have a palm oil where we process the fruits to produce the oil or to extract the oil in factories that we call palm oil mills. And as a byproduct, we have effluents. These effluents can be treated to get biogas, and this biogas can be turned into renewable energy or electricity. In terms of locations, all of these palm oil mills usually are very far from the national grid, from the main connection to the centralized grid, because of the nature of the trees. So what tends to happen is these mills will actually use this waste biogas to generate electricity, and this electricity will be used to power the housing or the quarters of the workers. So I remember back when I was working in one of with one of these mills, they were worried. They were quite conservative. If they have too much biogas and there's not enough demand, what are they going to do? What are they going to do with the waste? Because this biogas comes from the waste. But as soon as they connect to these quarters, the workers have families, and then as soon as they have access to electricity, the family, the ones that's not working, the wives, the daughters, even the sons, they started to make cottage industry, because they want to make more money for their own family, isn't it? So this actually, they bake cakes, they sell local products, and this actually produce a lot more, or consume a lot more energy that they're actually producing at the mill. So all the way that they have to ration the electricity. So this happens, and I'm sure it happens to the rest of the world as well. Once you give access, the demand is just going to increase. Yeah. Another indicator is what we call the clean cooking fuels. So remember, energy is not only electricity. We mainly use energy for heating, cooling, and also electricity. So this graph shows the same. As more and more people have access to clean cooking fuels, meaning they put more strains on fossil fuel. Clean meaning you're looking at like cooking gas, the gas stoves. And the target is, of course, as more and more people develop, this will drop further, and then the demand for clean cooking fuel will increase. We are expecting it's going to increase about 2.5% yearly to 2050. And then by that time, we have close to 10 billion people in the world. So it's going to put more and more strain on energy. The second item is the security. So this is a snapshot of oil movement in 2020. I'm not going to share all the energy. I'm just going to share two, which is oil and gas, because this is the major ones. Over 70% of the world oil and gas reserves is actually in the Middle East, North Africa, MENA, and the former Soviet Union, FSU. So what this means then, the security, the availability that you can get energy on demand really depends on where your energy comes from. So this can drive up prices. This can also drive up, the actual availability itself. So the next slide shows the same, but this is for gas. So as you can see, the gas movements mainly comes from here. We are a net gas exporter, but we still import as well. So not everywhere have the same access to the same amount of energy. Okay, so Ilham, you have question on this. I think I can leave this to the later part, if that's possible. Because we have some slides on that as well. And of course, the final one, what is more significant now, is the impact to the environment. So you can see here in the graph, this is the CO2 emission throughout the years. And these dips that you see directly relates to the energy production or energy consumption. You can see when the dissolution of Soviet Union, a lot of industry or factories shut down. And that causes a drop in energy or energy usage, which correlates to a drop in CO2 emission. Global financial crisis 2008, same thing happened. So this is the collapse of the housing market in US and Europe. So a lot of factories shut down, a lot of businesses stop. And then you can see the drop. Drop in energy means drop in CO2. And the ones that we just came out of, the pandemic, this is bigger, even bigger. It affects the whole world. So the whole world basically stopped for months. We're not producing anything, or the energy demand drops a lot, and the CO2 emission also drop a lot. So this is proof whatever happens to the energy side, we are actually producing the CO2. When we stop using energy, we stop using CO2. I don't know if any of you remember, young enough to remember the Asian financial crisis. So that only affected a small region, if you think about global, but you can still see a small drop here, 1998. So even, Japan, South Korea, Taiwan, including Malaysia, Hong Kong, our industries were disrupted because of the Asian crisis. You can still see a drop in CO2 emission.
Okay,
Yeah.
Dr. Adlan, so sorry to interrupt, but I think we have some questions here. Emme, if I'm pronouncing your name correctly, do you have a question for Dr. Adlan?
Yep, go ahead.
You can just speak out your question if you're comfortable with it. If not, you guys can always give us your questions in the chat box as well. Sorry, Emme, we can't really hear you, yeah?
Let me unmute. Hello?
Hello,
Hello,
yeah, go ahead.
Yeah.
Okay, can you hear me, right? Right. Okay. So, regarding to the graph, this one is for energy consumption. This one actually,
Sorry, you are breaking up. I can't really hear you.
So, right now you can hear me, right? Or still hearing some noise? No, right?
We can hear you a little bit, yeah, but it breaks up from here and there.
Okay. So now, hello, can you hear me? Yeah.
Maybe if you can type the question.
Yeah, sure. It's okay. You carry on. I will type my question. Okay. Okay.
Yeah. Okay.
Yeah. Okay.
Yeah, I just continue for a bit because there's not much left on this part. Okay, yeah. So we were talking about this graph. This map just shows, where the energy is intensive, also where you can see the CO2 emissions happening. So you can see the regions where it's less energy intensive, it's less CO2 emission. So what happens then? Yeah. So when you get all this CO2, I'm sure you heard of this, the greenhouse effect. Do you want me to explain to you, or you're okay with this? Or maybe you should explain to me. No takers? Well, for CO2 is actually a greenhouse gas. It acts like an insulation. It acts like a blanket over the Earth's surface. So we have heat that comes through from the sun. It warms the Earth. It warms the Earth's body, and then it gets trapped under this blanket, under this layer of gas, or inside the atmosphere. So any greenhouse gas, so CO2 is the main one that we have to deal with, actually increases the temperature of the planet. So people might think, okay, so it's just going to get a bit warmer. Well, what you have to remember is the atmosphere is fluid. It's a layer of mixture of gases, and these different gases at different locations, get heats up at different rates, and will try to re-equilibrate. It will try to balance itself out. So there you have new movements, from the hotter regions to the colder region, high pressure to low pressure, and so on. And these movements actually changes the weather pattern. And this is what we call the climate is changing. So the impact is quite bad and I'm sure you are aware now. I talked about this maybe 20 years ago, and then I said, oh, we are already seeing it happening slowly. But maybe in the last 5 or 4 years, it's been happening quite frequently. If you talk about the temperature, or if you hear in the news, every region will say, this year is the hottest on record. And then in next year, it will say, oh, this year is the hottest on record. And then come to 2023, it's still the same. This year is the hottest on record. So, it's just going to get hotter and hotter and hotter. But that's not the main issue. The main issue is actually the change in weather patterns. So when this change happens, you can start to see this, and this put a strain on us. You have the vegetation is affected, which means our food production is affected, which means our food is getting more expensive. And we can see this happening now. And then you see a lot more fires and a lot more precipitation. So this happens at the same time. Some places get really, really hot. You get wildfires happening here and there. Some places get really, really cold. So you have very harsh winter. So we had a very harsh winter a couple of years back in the US, and they're expecting the same again this year. And then we have rains. This heating evaporates a lot of water. And as you know, Newton says what goes up must come down. So this water then comes back down as rains, and we have a lot more precipitation, a lot more flooding. We see this. Global sea rise is happening now. And then we also see this happening now as well. The glaciers are retreating, which means it's actually melting earlier in those regions, and again, more floodings. So we are running out of time, but we are not running out of options. What this means is we actually know what we need to do. We need to reduce the amount of CO2 in the atmosphere, and if possible, other greenhouse gas as well, because CO2 is not the only one, but it is the one that is so much in the atmosphere. So I have a question from Saga here saying, what is life without carbon? So without CO2 in the atmosphere, people have done this calculation, physicists have done this before, and simulation as well. Actually, the Earth surface temperature would equate or would equilibrate at about -16 degrees Celsius. So this is why previously we have ice ages and so on. When the amount of CO2 in the atmosphere is low, the surface temperature becomes very cold. We can actually get ice ages. But this is unlikely to happen because the amount is just so much now. What level do we want? Okay, so we want to reduce back to, if possible, pre-1990s level. So this is why you see a lot of publications, a lot of research, and they talk about 1990 levels. Better if you can go even below, because I've seen some newer simulations saying that actually most of our studies look at the northern hemisphere, where there is another phenomenon called global cooling, which happens at the same time as global warming. But if you look at data from the southern hemisphere, which was not collected back then, they didn't suffer global cooling because of some pollutants in the atmosphere. And their global warming started in the 1960s. So now people are arguing maybe we should go back down to 1960s level. But let them argue. They're scientists. We are on the other side, and the engineers, once they are firm on what we need to do, we'll do it for them. These are all peer reviewed. This is nothing new. You cannot deny this anymore. This is even, I would say, even 20 years ago, you cannot deny this. The links are too clear. But of course, they are, like what I said earlier about the global cooling, that is caused by some other pollutants. and it masks the effect of global warming in the northern hemisphere. So this is where you have to look at the data. Don't just look at only US or Europe. You have to look at data from Australia and New Zealand, and you will see a very different picture. The journals are out there. I mean, I don't have to show you now. If you look at the links in the slides, from there you can also find a lot more journals and references that are linked to their studies. So these are all verified. You can't say it's unverified because there's more than thousands of scientists have done this. You can also search the history of climate change, which I will touch a bit about as well. So this Eric's question is significant as well, because to me, I share the same opinion. What we are seeing now is what's happening 100 years ago. So this is where my next slide takes. So you might think like, okay, I've already preamble a bit. You might think that this climate science is new, maybe in the last 20, 30, 40 years, but actually we have known something very early on. This is 1896. If you come from a chemical engineering or chemical background, you might recognize the name, Arrhenius. You might have come across his equation. So he actually published in 1896 the influence of carbonic acid. At that time, they don't separate the CO2 and H2O that comes out. And it was condensed, the CO2 mixed with water, it condensed into carbonic acid. And this is, at that time, this is the only science that they can do. They call any products of combustion carbonic acid. It's a mixture of CO2 and H2O. And they know it actually increases or influences the temperature of the Earth. Especially at that time, global cooling hasn't happened yet. So even then, they know. This is an article from 1911 in Popular Mechanics. The remarkable weather actually talks about the loss of agriculture products because of this. Even then, they know, or they actually estimate how much coal they are burning produces how much tons of carbon dioxide. This is 1912, remember? And even then, they realize. But the motivation is slightly different. And this is 1930, the first time the word climate change is used. So this was from another article, and they talk about the same thing as well. At that time, they were more concerned because they also discovered the ice ages. They were more concerned about the Earth going into another ice age. So actually, even though they see this warming effect, they are very happy about it because they think it will deter or it will stop us from entering into another ice age. But what they didn't realize, what we put out is just so much that we cannot absorb it. We cannot absorb it. So this is why we talk about the CO2. Actually, the main sequestration is the seas and not the trees. You can have vegetations, high CO2 also will have high vegetation, but we chop down all our forests anyway. So most of the CO2 is actually absorbed by the oceans. Okay, so let me just go back to these questions. So you talk about solar panels and all that. So again, this is the disparity. There's an inequality happening. And as you know from if you came in earlier from my own research, I'm not a solar person. So I do agree with you. Solar is just one of the things that we can do. And actually, because the sun rays hits the earth, plants actually absorb the solar energy and convert it into chemical energy. for us. So in fact, without much of those minerals and so on, we can actually use this bioenergy. But like I said earlier as well, we have done too much of deforestation. You know, most of Europe and North America was forest at one time. That there's not enough vegetation to absorb the CO2 and not enough for us to actually rely on bioenergy alone. So we actually need to use all hydro, even nuclear, any kinds of resources that is less polluting, or in fact that doesn't produce fossil carbon. And the problem with fossil carbon is this carbon is already stored underground. It's already not in our carbon balance, but now we're just pumping it back into the atmosphere. So this is why we need to reduce it. Okay, MA, let me know if I get your name wrong. Organization is still R&D reducing air pollution. Okay, we are doing. In fact, I'm going to share some more slides on that as well. We are doing we can go back to here. We know what needs to be done. We know what can be done. We're just not doing it fast enough. So this is why you guys are important. This is why we offer this course. We've been offering this program for a while now, even in the UK and Dubai. We offered in Malaysia since we started back in 20, if I'm not mistaken, we offered back in 2013, even before we moved to the new campus in 2014. So this is where, and I can see our alumni is actually changing, especially in Malaysia itself. So I can share about that as well later. So climate change. So renewables are not fossil fuel free at the moment, but we are just starting. We are just starting, and we are trying to do as best as we can. And I need you guys, the workforce of the future, to do a lot more. At my stage, when I started 20 years ago, there was not much money around. There was not much awareness around. I have to be the one that gives the awareness. But now I can see my ex-students are out in the field, and I try to support them as much as I can, and give you more awareness as well. Nuclear not only relies on uranium, even though this is the most efficient way to get nuclear. But again, I can share a lot more on this as well. When you talk about efficiency, really, if you are relying a lot on fossil fuel, of course, you want to be as efficient as possible because you want to reduce the amount of CO2. But then if you're relying on abundant other sources of energy, for example, even solar, probably efficiency can take a step back, or just a step, not many steps back. Of course, if you are more efficient, meaning you produce it at a much cheaper cost, so that will help in the energy security and energy equity. But if it's abundant in the first place, probably you can use that. So similar with nuclear, if you have others like thorium, it's not as efficient as uranium, but if you have a lot of this, probably this is something that you need to look at, because it doesn't produce CO2. Okay, in terms of colonialism, I cannot answer that because really not part of my field. And even if I do have my own views, I'm not equipped to tackle that. So I'm not going to go into that conversation. Okay, I just shared this one picture. I don't know if anybody recognize where is this. What am I trying to say with this picture? Anyone? Saga, you have so much to say. Do you know? Can you maybe guess where this is? Part of the world? Okay, I can just share with you. This is actually in southern Germany, one of the towns in southern Germany. You can see a lot of snow and ice. Yeah. But this actually happens in the height of summer this year. Yeah, so it's quite recent. Yeah. This is another picture. You can see New Straits Times there. I don't know if you know where this is or can guess where this is. So New Straits Times showing that surely it's in Malaysia. So any Malaysians out there, maybe some of you from this region, or you can guess where this is. No, this is Pahang, Sungai Pahang, our largest river in Peninsular Malaysia, and it has been having problem. It's drying up. You can see the river bed here. Yeah, so this is supposed to be a river all the way. There's a small island in the middle or sandbanks, but then you shouldn't see this. Yeah, this is the ikan pate in the cages, where they farm fish. And now you can see they cannot farm fish in this kind of condition. There's no water. This picture was quite recent as well. I don't know if you can recognize from the writing where this is. Oh, nobody watched the news. Nobody into K-pop. You cannot recognize the Korean writing. Yeah. This is the flooding in Seoul that happened again quite recent as well. So where in that one day alone, over 40 lives are lost. So you can see all these are quite devastating. And this is the most recent. I don't know if you've seen in the news, the most recent, only a few days back, maybe 5-6 days ago. Where is this?
Hawaii?
Yeah, this is Hawaii, in Maui. Yeah, so they have the big forest fire where they have never had for a long time. I think the last time they had was in the 1920s or something like that. Yeah. So you can see it's happening now. It's very devastating. You have life loss, you have economics, livelihoods being lost. You have housing, you have a lot of devastation. But what's more alarming is all of these pictures that I shown happens in the past 3 weeks. Yeah, so it's not only the devastation that is produced, but also the frequency that's happening. Yeah, and not only that, I purposely choose these 4 pictures because of the regions they're happening. So it's happening everywhere. So it's truly a global crisis, and it's truly happening more frequent, and it's affecting us all. Yeah. So this is in Europe, in Malaysia, in Korea, and also in Hawaii, and in the US. So we know this is something that we have to tackle. There's no way around it. We know why it happened, and we think we know how to reduce it. It's not going to go away immediately. If I quickly go back to this, it says the effect, this is 1912, the effect may be considerable in a few centuries. And from this article, we only have 1 century. So, so we're looking at a few more centuries of climate change. But then it's just gotten so bad now that it's happening so frequently. Coming back to that, CO2 have a very long life. Before it was about 100 years. Sorry, not 100 years. Before it was about 90 years in the atmosphere, and then it's going to be absorbed by the oceans. But now the ocean has what we call, in some simple terms, too much of CO2 already. Is absorbing, or is the rate of absorption is less. So now the latest estimation, CO2 in the atmosphere will last for over 100 years. So really what we are seeing now, the effect is what's happening 100 years ago, 90 to 100 years ago. Yeah. Okay, how is it attributed to climate change? Because the temperature is too high, and they haven't had their share of rain. They haven't had their share. They have some droughts over many days or many weeks. So the ground is dry, and then any spark, because of the dry ground, because of the droughts, because of the high temperatures, they have the highest temperature on record as well this year, which is higher than their record last year, which is again higher from the record last year. So that causes the fire to spread this much. If normally they have very humid temperatures, the grounds are humid, humid atmosphere, the grounds are wet and humid, they won't have this big of a fire. So even if they don't have rains for many days, the grounds are still humid. If the temperature is lower, they won't have this such a big fire happening. Yeah. Okay, it's time for a short break. Yeah. In the meantime, I let you answer this poll. So I'm gonna set up this poll, and I give you maybe 5 minutes, to stretch your legs, to do whatever is needed, grab a coffee or something. So we can come back just before 7. Let me just escape this. So during the break, you can do the quick poll. Let me just see. Oil, gas, coal, and renewables. Okay, we'll come back in about 3 minutes, and I'll see your responses. I have my coffee. Okay, shall we continue? Yep, I see a thumbs up. Okay, so I see most of you say oil, yeah? Actually, this is still quite a trick question as well. Let me just turn on the big view. Yeah, so these are all located in Malaysia. This is in Pengerang. They're still building, but parts of the refinery are there. This is our most, actually now second newest gas plant. This is Tuanku Jaafar Power Station, Negeri Sembilan. This is our Jimah coal power station, and we have these renewables all over Malaysia. So the question can actually be answered in two ways, but I guess even for both ways, okay, at least for one of them, two of you is correct. So our largest consumer is actually industry and residential, and for that, we actually mainly use gas for power generation and also for powering our industry, our manufacturing, and so on. So we talk about primary energy source or primary energy supply is actually gas at about 60%. But then if you only talk about electricity generation, the amount of already consumed for electricity generation is actually coal. And that stands at about 60% as well, if you talk about only electricity generation. Oil is mainly used in our transport fuel, and it is not our main use of energy. Industry and residential is higher. So industry including power generation. Renewables are, again, you can look at it both ways. If you talk about the primary energy source, it stands at about 9%. But if you're only talking about electricity generation, it's around 17-18%, including hydropower. So it's gas and coal, and these are still fossil fuel. So we mainly rely a lot on fossil fuel still in Malaysia. Okay, so now only I'm aware of the time. It's 7 o'clock, so I'm gonna peel off the title itself. So I talk about sustainable energy transition towards a net zero future. So these are just terms. But I think I'll give you the basics of it because you're going to be hearing a lot more terms. And from the responses that I see, some of you are aware of some terms as well. But make sure that we are using the correct terms. So sustainable development is an initiative collectively started by the UN, all 197 signatories of UN. It started with their Brundtland report, which by definition means developments that meets the needs of the present without compromising future generations to meet their own needs. Excuse me. So the keyword here is the needs. So it has to identify what are the needs, and then by 2015 they come up with these 17. So these 17 needs, or what they call the Sustainable Development Goals, the 17 goals. Some of you might have seen it before as well. And when you talk about energy, especially sustainable energy, we are mainly talking about goal 7 and goal 13. But of course, when you try to produce and distribute and consume energy, you do affect the others as well. Because you need energy to develop, to have a quality of life. And then in doing so, you're affecting almost all, mainly 1, 9, 11, 12, 14, and 15, on top of 7 and 13. Oh, you haven't seen the screen? What happened? Can you all see the screen?
Yeah.
Yeah, it's still sharing. Yeah, so I'm not sure what's happening on your end. I can still see sharing here. Okay, so we're just going to focus on these two. Yeah, so this is the latest report. So this is the advanced report 2023. Advanced meaning the final report is not out yet, but they do share the advanced version first. And as you can see, so this is where, okay, not 657, 675 million people is still doesn't have access to modern energy, and still 1 in 4 people cooking with unsafe or unclean fuel. So meaning that these two is still ongoing and we have to address this. But at the same time, if you look on the other side, we are actually right at the tipping point. Yeah. So what it means that there's a point where the climate doesn't correct itself, or it takes a long time for the climate to correct itself. If we pass this, and we are already leaning to one side, we're leaning towards this end. So this is what we mean by we are running out of time, even though we know what needs to be done. Yeah, you can look this up at IPCC website. I forgot to put the link, but I have the links of everything else in the slides. So what we need to do, then we know we need to remove or reduce as much CO2 as possible. And this is a prediction by Irina in the energy transition. So you start to see this name now, from sustainable, and then we have energy transition. So we need to do the transition from heavily emitting CO2 into less emitting and even no emission at one point. So we have to reduce this lower and lower. By 2030, this is what the target is. We are actually quite far from the target. So the next 7 years, there's a lot of things to be done. Yeah. Yes, Saga, I can agree with that, but then having too much carbon is also a bad thing, as you can see. All those lives lost because of climate change and so on. Yeah. So the mitigation by 2050 has to be done by this. We want to remove about 37 gigatons of CO2. And even if we remove this, we will go back to 1990s level, meaning that we are still a lot of CO2 in the atmosphere compared to 1800s, 1700s. So don't worry, we won't run out of CO2 in the atmosphere. Yeah. We've been living for millennia before that as well. So it's not really a concern. So this, how do we do that? We have to reduce about 25% by renewables, 25% by energy efficiency, about 20% by electrification, and so on. BECE, CCS is bioenergy combined with carbon capture and storage. So not only we are removing fossil CO2 from the air, but we're also removing natural CO2. And then here is CCS, is carbon capture and storage. So we are removing fossil CO2 from the air. And because we've put so much already that we need to remove this. Yeah, thank you. Oh yeah, I cannot see your full name. Yeah, so the next part then goes into energy transition. Yeah, so in the energy transition, we need to increase REEE and electrification. Yeah, so first time, so you might want to learn some more. So in the traditional power system, this is what we have. We have a centralized either fossil fuel burning or thermal plants, or even renewables from hydro and wind, goes through the main grid, and then the grid distributes to the consumers. Now we do have also at the consumer level, either residential or commercial, some are generating locally on site for own use. Yeah. So this is what we are seeing now. Yeah, we are seeing this even in Malaysia as well. We have a lot of places where you have solar panels on the rooftop, for own consumption, and maybe selling locally, selling to the neighbors only. Yeah. But in the future, we are going to see this. Yeah, we're going to see a lot more localized generation, and at the same time, if we are repurposing this instead of thermal from fossil fuel, but thermal from bioenergy. Yeah, we also have storage where we capture the renewables when we don't need it, and then we can redistribute into the grid, or we can have storage in the forms of mobile. Yeah, so even your EVs can become storage as well. So when you have excess solar and you're in your office, you're in your house, you're not using it, you can store the energy in your vehicles, and then when you come back home, you can use that at night. Yeah, we don't have solar. Yeah, so you have a lot of things going on, but then it becomes more complicated, and we're not only relying on centralized generation. So this is how the transition will happen. It's already happening now. So you have the traditional power system where you have centralized network and then you distribute the energy. But now we're going to have a lot more self-generation, self-distribution, even large-scale storage. Yeah, so this is where you might have heard of this term as well, the 3 Ds of energy. So we want to remove or reduce carbon, so decarbonization. And then we have smaller distributed generation or decentralization. And in order to have this complicated network, you have to go through this digitization. This has to happen. If we don't do this, these two might not happen in a big way that we want. Yeah. Yeah. So we have been going, transitioning within the last decade very rapidly, including Malaysia. There's an index that you can check. So this is the Fostering Effective Energy Transition from the World Economic Forum. And in this report, we are number 39 in the world. So we are also moving fast in this field. So we're not saying that we're not doing much. Second in Southeast Asia. And we have this as well. Part of the digitization, we have the energy management systems. So a lot of companies are already abiding by this ISO. So this transition is happening, and is what's going to be continue to happen, especially to reduce the impact of climate change. So you will see this happening more and more and more, which means we will need more and more people to work in these areas. So this is what's happening in Malaysia. We launched this at the end of last month. So we have the National Energy Transition Roadmap, and we identify these 10 catalysts. And you can see efficiency, renewables. We want to introduce more hydrogen. We want to introduce more biomass. And then, of course, green mobility and carbon capture. So these 10 catalysts have been identified, and this is what Malaysia's focus will be. So in the next coming decades, towards 2050, this will be where most of the jobs or engineering jobs will lie. So this is what we are aligning ourselves to as well. And the last part is talk about the net zero future. So net zero is actually a relatively newer term because there's so many terms out there, carbon neutral, and RE targets or carbon targets and so on. Actually, it comes about because everybody have their own definitions and targets, and everybody been pushing it out so much that the greenwashing is abundant out there. So greenwashing actually is not new. Again, I heard the term, or not heard because I wasn't even born yet. But I seen the term occur or come about even from 1970s publication. But because of that, we need to have a more standardized view. And this comes about because then we say there's no way that we can remove all emissions. So there will be some activities that will emit, but there is some activities that will absorb, or we can also increase absorption. So this is where you have reforestation coming in instead of deforestation. And then you have carbon capture and storage instead of just leaving, especially with bioenergy, instead of just leaving the CO2 in the atmosphere. So what we meet then from all the models say, if you want to curb to 1.5 degree, the balance between emission and absorption, net zero, must be achieved at around 2050 for CO2. And for others, greenhouse gases, the rest, between 2060 and 2070. And I think we might miss this. I have to be realistic. A lot of scientists also are saying that we might miss this. If we want to limit by 2 degrees, you have to achieve between 2070 and 2080 net zero of carbon dioxide, and then between 2080 2090 net zero of other greenhouse gases. So you can see this is spanning almost a century. So the effect is actually true, centuries. So here we are now looking at actors instead of countries. Before this, when they have target, EU have target of reducing by 20%, and then Germany have a target of RE of 50% and so on by certain years. So they all have different targets, and then the countries really cannot control because they realize most of the energy or industry that's producing this, the energy sector, are held by multinational companies that work across countries. So now the target has to lie on the actors. So the actors are non-state entities. So it can be companies, it can be non-profit organizations, and so on. No, I know we want to achieve a balance. So if you can absorb as much as you produce, then it's good. Okay, it's right. But then they still emphasize on reduction as a key strategy. So the idea is if you can reduce in the first place, if you don't produce as much emission in the first place, then there's less absorption that you need to put in place. So reduction is a key strategy, and instead of countries, the actors are now companies. So I'm aware of the time, so I'm not gonna read through this. You can read through in your own time. But this is taken from the Carbon Trust. So net zero is relatively new, so there's not much reporting done on it yet. If you compare to sustainable, or if you compare to energy transition reporting and so on, there's more out there. But in terms of those who already have a target, so I know the map talk about countries, not actors, but this is the only way that we can show it on the map. So Climate Watch show this. Again, another non-profit organization, independent group of scientists. And they say those that have pledged by 2050, the one that we say we want to reach, if we want to meet 1.5 degrees, only accounts for 31% of global emission. So the other 69% is not going to be curtailed. And this is only a target, saying that, okay, I pledge to do this. Do you actually meet your target? We don't know. So this is why I'm quite skeptical that we are going to reach that 1.5 degrees warming. We are going to limit to that 1.5 degrees warming. But if you look at the other simulations, there are other things at play as well. 1.5, 2, 2.5, 3, even up to 4. So it's going to be bad, but it's not going to be the worst. So we still have to work on it. Okay, so this is I wanted to do another break here, but then of course we don't have much time. So I just show you this, and I give you the answer. So I give you a question, but I answer for you. So similar to the first question, there's two ways of answering this. The largest renewable energy generation is of course hydropower, because we've been doing hydropower for a long time. Our first hydro dam is in 1926, still running now. and it contributes to about 11, 12, depending on which year, because the amount of hydro that we can generate depends on the amount of water that we can store in the storage. So it hovers around that number, around 12% of the energy mix. Yeah. But then, of course, the others, if you, for example, if you compare solar and bioenergy, solar, we have the largest capacity, but in terms of actual generation, bioenergy have maybe about 1/3 of the capacity of solar, but they're producing or generating close or to the same, or maybe 90% of what solar is producing. Yeah, so it's actually more worthwhile to have. Yeah, but we don't have this much yet. Yeah, so there's still plenty of room to grow. In terms of wind, yeah, so in terms of any resources, actually, if you talk about renewables, if the resource is not there, then no matter what technology that you use, you're not going to be able to generate. And we found that in Malaysia itself, the wind is just too low. We're not actually generating much. It's very, very, very small, and in only 1 or 2 locations that we can harness wind. Yeah. Okay. So the next part is now more on the programs itself. Yeah, before I go into that, any questions? That is not going to take too much time. Yeah. You know, Saga, probably we can have a separate discussion, because to answer all of this is going to take a long time.
Dr. Adlan, I have a question for you, if
Yeah,
there's
go
no
ahead.
problem.
Yeah.
Sir, would you tell us about the subjects we're going to
Yeah. So now
study
I'm going to go
in
into this.
MSc Renewable Energy Engineering?
Yeah, I'm going to go into this now.
Yeah, kindly also tell us about the subjects and the thesis and everything we're going to study in this program.
Okay.
Thank you, sir. Thank you so much.
Okay. Let me close this. Okay, so the next part is talking about the program itself. I can skip that. So in terms of courses, so the subjects are called courses. So the degree is called a program. So we have these courses listed here, where you have to take the 6 or 5 core courses plus 1 dissertation, and then you have to select another 3. So total of 8 courses plus 1 dissertation. Foundation of Energy, Renewable Energy Technologies, and then Economics, Advanced Renewable. This is actually to prepare you for the dissertation, so critical analysis. And then the optionals is shared with the mechanical, you have the heat transfer. Shared with the electrical, you have the electrical power system. And you have demand management, environmental impact assessment. And another one shared with the mechanical, advanced thermodynamic applications. So you have to choose 3 from this 5. The program itself is accredited by Energy Institute. This is where I talked about the link earlier. This is the only program in Malaysia, in fact, in the Southeast Asia region, which is accredited by Energy Institute. And what it means that every student who graduate with this degree has done the first step to become a chartered engineer with the Energy Institute or with the Engineering Council UK. Yeah, so it's an accredited degree. So from here, you can be a chartered engineer with EI UK. Yeah. Another thing is we are one of the 6 learning affiliates. So learning affiliates, sorry, there's 4 now. There's 4 learning affiliates in Malaysia. The other 2 is in the other Southeast Asian countries, meaning that every student of the school becomes, or not becomes, they can apply for a student member of the Energy Institute for free. Yeah, so you just have to submit the application form. You don't need to pay anything. You become a student member, and you have access to, knowledge of over 100 years in energy. You have access to 23 not 27,000 professionals throughout the world. So the Energy Institute is a very big professional body. So in terms of the credit hours, so in terms of what you need to do, if you do full time, so you take 4 courses in semester 1, 3 of the core and 1 optional, and then 2 core courses in semester 2, and then 2 optional here. And then, so this happens during September to December, semester 1. Semester 2 happens during January to May. And then dissertation is from May to August. There's no more classes, no more other courses. You'll be concentrating to do your research for 3 months for your dissertation. The entry requirements is you have to come from an engineering or sciences discipline. So for this RE, it doesn't have to be purely from engineering, but we limit to sciences. So it's difficult if you're coming from an accounting or economics background. But if you're coming, for example, from chemistry, biology, any of the physical sciences, and then environmental science, or any of the civil, mechanical, chemical engineering, or whatever, even aerospace engineering, you can enter into the renewable energy engineering program. In terms of the advanced mechanical, so when you talk about the energy transition, there's 2 parts. There's 3 parts: RE, EE, and electrification. When you talk about EE, this is where your skills is most required. So this is existing energy system, but of course we need to make it as efficient as possible so that we reduce. So this is co-firing biomass with coal. We want to reduce the amount of fossil CO2 compared to the natural CO2. This is if I remember correctly, this is another gas plant, and this is the Bakun Hydro Dam. So mechanical is essential and is deemed to be the most promising types of engineering coming out in the next few decades as well. So this is why we offer the mechanical engineering program as well. So in terms of the mechanical engineering program, we have these courses, less core courses. You only have this. So actually it's the same, 5 core courses, 1 dissertation, but you have a lot more options that you can choose from. And this program is accredited by IMECI. At the moment for Malaysia, we only started this program for the past 2 years, and we only have our first cohort this year. So it's not yet accredited for Malaysia, for IMECI, but it's accredited in the UK and Dubai. Hopefully in the next review, we will receive our accreditation, probably next year or the next 2 years. It depends on the number of cohorts or number of students that pass through the program. So in terms of core courses, you have the Professional Industrial Studies, CFD, Failure Accident. This is actually advanced manufacturing. And then you have the same. This is shared with the other master's program as well. And in terms of optional, you can see either you can go into fluids, you can go into advanced mechanics, you can go into thermodynamics. It's up to you. The way that we do it, one of them is in semester 1, the other one is semester 2. And the topics are actually not directly linked to each other. So you can, if you want, to take thermodynamics in semester 1, fluids in semester 2, or advanced mechanics, materials 2 in semester 2. But somehow, if you do the same one, it's more complete. So I don't know, it really depends on the employer or your future employer. If they want you to focus on a certain area, they might, you might be worthwhile for you to take 1 and 2, fluids 1 and 2, for example. But if they want you to be more diverse, probably you can take fluids and then you take dynamics, or you take dynamics and then you take thermodynamics. That is up to you. You can also take renewable energy, which is a core subject of the MSc Renewable. So this is an optional for MSc Advanced Mechanical. Same thing. If you take full time, it's 3 semesters of 12 months. So from September to May, September to December, January to May, May to August. and 4 courses in 1 semester, and then dissertation during the summer. Yeah.
Sir, I have one more question regarding MSc
Yeah.
Renewable Energy Engineering.
Yeah.
I would like to ask you that suppose if someone does MSc Renewable Energy Engineering, after that, if someone wants to do PhD, then what are the areas of research that she can do?
Sorry,
Can
to
you
do what?
elaborate? Suppose if we want to do PhD, so can you elaborate some research areas after renewable energy engineering?
Yeah. For the dissertation, actually, you will be introduced to research, and then both. For both programs, we have our experts, researchers, which cover all kinds of fields. Yeah? So you can actually specialize into whatever align with your interests. For example, myself is more towards bioenergy. We have a specialist in solar, specialist in energy storage, hydro, and even wind mechanics. So that one is where you will decide on what is your interest, and from there on, in your PhD, you can continue in working in that research.
So actually, I have done my chemical engineering bachelor's. So if
Yep.
I'm interested in MSc Renewable Energy Engineering, can I pursue PhD in chemical again, or will I have to be linked to renewable energy engineering?
For the PhD or even for the dissertation, you can relate back to chemical, because chemical is everywhere. Even in solar, we use a chemical as well in the manufacturing, and then of course in the others, in the biofuels and so on. So you can always go back to your chemical in your dissertation and your PhD.
And so the last question is, what is the employment status of MSc Renewable Energy Engineering? Like, for example, if someone does the post-graduation in this course, then after that, what are the employment sectors in Malaysia? Can you specify it regarding Malaysia?
For Malaysia itself, because we are still relatively new, I can show you the global. We know it's going to grow. Every company is doing renewables. Even most of our alumni actually came from Petronas and Shell, because those companies are asking them to look into renewables and what they call the new energy division. And I would say most of them have gone back, and they are people who are leading this division. There are people who have moved on from leading this division and now is part of the EPU, the Economic Planning Unit, sitting at the government level. We have alumni in SEDA, the Sustainable Energy Development Authority, and we have alumni, dictating in other companies as well, on the way forward in terms of renewable energy efficiency and so on. So I would say the job prospect is very, very high. In fact, in my LinkedIn, I always see, because I follow several renewable companies and even non-renewable companies. They always, almost every week, there's jobs in this area. So I would say it is what we have now in the situation in Malaysia, especially. We don't have enough specialized or skilled workforce to go into this transition. We already started. We have the roadmap. So we have to do it now. We are already doing it, but we need the people to actually do it. And this is where our alumni are doing it. And hopefully, if you guys join us, what you guys going to be doing as well. Okay, I hope that answered your question.
Yeah.
Thank you, sir. Thank you.
Ilham has raised his hand. Ilham, you want to ask your question?
Yes, I have last question maybe.
Yeah.
Yes, thank you for the opportunity. So I want to ask about the question about the focus research in the Heriot-Watt, especially in Malaysia. My research is about exploration energy for renewable energy in the offshore. And then, is it suitable for me to enroll PhD, and can Heriot-Watt support my research? Thank you.
Okay, so after the degree, you become an alumni. If you rejoin us for PhD, this is there's discounts available. Yeah, I think this is an incentive. But more importantly, I think I can share my own experience because I work with my supervisor even from undergraduate. He was my undergraduate degree project supervisor, and then I went on to do a research, and then I continued to PhD with him. And after that, I stayed and do a postdoctoral research with him as well. Because once you actually do something that is in line with your interest and your passion, it's best to stay with the same team, because you just grow from there. So this is something that I see happening with my other colleagues as well. We tend to come back or stay on within the same team if the opportunity arise. I know there's some people who are not so fortunate, they have to get back into the workforce and so on. They cannot continue to study further. But the opportunity is there, and it's best to continue with the same team, so to speak.
Yes, thank you, sir.
Okay. So this last slide from me, just showing you some pictures of what we are doing. I know we conduct site visit, research seminars, and then we invite guest speakers as well. I'm going very quickly because I know we already past time. For the next set of slides, I'm going to pass to my colleague Christine to share more about the programs, especially on the enrollment.
Yeah, thank you, Dr. Adlan. Right, so just to share with those who are interested, currently the fees that you are showing here is actually for the local student fees, right? Fees for international students is a little bit different. It is not here because for international students, application for September is closed due to visa processing deadline. So for those who are from international who is still keen, the next intake will be in January. But please let us know if you are still keen. We will send you the fees for the January intake for international. So for the local students, the fees are as per shown. It's a total of 47,250, but paid by semester. All right. So if you're a full-time student, your program is 1 year, 3 semesters. You can pay by semester. If you are taking it part-time, you will stretch to 2 years. So it's a total of about 5 semesters in total. All right. So again, payable by semester. Okay. Next slide. Okay. So the program will start on the 11th of September. So we will have an orientation on the 9th. And so ideally, if your applications can reach us by 4th of September, that would be good. Alternatively, if you still want to speak to us or want to visit the campus, you can come by. This weekend is our application day on the 19th and 20th of August. We are open from 10 to 4. So you can come by during this time to ask further or to submit your application. All right, if you need help. All right, okay, next slide. All right, so here you can actually, if you have your phones, you can also scan for more information. But again, the slides will be sent to you. We have a corporate discount for companies. If you send staff two or minimum of 2 staff from the same company, you get a 25% reduction in tuition fees. There is also, if you send up to 4 staff from the same company, you get up to a 30% discount. All right. We also have early bird waiver. If you register early, you will get I think before 20th of August, you will get a 4,000 ringgit reduction of the fees, right? In 20th of August, extra 4,000 reduction. We call it the early bird waiver, right? And a 1,000 off for registration fee. So this will be deducted in your second semester. It will be given back to you in your second semester if you register early, right? Okay, any questions?
Yeah, I've been answering some question in the chat.
Okay.
If you're still around, yeah.
All right, okay, now is the time for Dr. Adlan to look at all the chat questions. Thank
Well,
you
ma'am,
for-
I have a question.
Yes.
Ma'am, I have a question.
Sure.
In the picture, in the last picture, I've seen that it's written that it generally intake it's only for part-time, like for local students. Can you elaborate for international students in detail?
Okay, international students, if you are coming to study, only to study, you have to apply for a full-time visa, full-time study visa, right? Because the immigration in Malaysia requires that all international students coming in just for the purpose of study apply for a full-time study visa, meaning you cannot seek employment on a full-time student visa. The only work you are allowed to do is I think up to 40 hours a week during semester break at some areas of let's say, like, for example, restaurants, convenience stores, this kind of work is basically for up to 40 hours a week during semester break only. So you're not encouraged to find employment or full-time employment. You can just work as a part-time, but limited to 40 hours a week during semester break. This is the immigration requirement. But if you are employed in Malaysia, you have existing employment pass or a work permit, you can embark on part-time education. So all you need to do is to get endorsement from your existing company in Malaysia saying that, okay, the company, recognize and support our staff's upskilling, and we support his education or his interest to study, and then get an endorsement stamp with immigration. You don't have to apply for a visa. You can just continue to come in and take the program with us.
And ma'am, is January intake open for international students because it's written part-time only?
Yes. Okay. Adlan, if let's say students were to come in for January, from international students, would you be able to have a full-time program for January?
For January intake is at the moment is only for part-time, unfortunately, because we
Okay.
don't have the number of staff to do a full-time for January intake.
Okay.
Yeah, so best for international actually is to come in for September, especially because of the visa restriction,
requirement,
isn't
yeah.
it? Yeah.
And the last question, sir, is that what is the fee enrollment? Can the international students also get some fee discount on their fee?
So fee discount, normally we have the early bird waivers. It's around 5,000 as well if you apply within a certain deadline. But it's only for that it's a one-off 5,000 ringgit. Yeah.
If we apply early.
Yes, if you join early, correct. So for international currently, because for visa, it takes about 7 to 8 weeks to process your student visa. So application has to take place 2 months before your intake date. So if the intake is in September, application should come in by end of July. Latest, very latest.
Okay.
Yeah.
And sir, Dr. Adlan, I have a question for you. Is that you told us about the core subjects of renewable energy engineering. May I ask you that how are these kind of subjects like foundation of energy, the economics, and these things? Are these related to solving problems and strategies? Are these related to presentations and skills, or are these related to just simple theory and reasoning? I just want some detail about these courses.
Yeah, at the master's level, you are expected to do some level of self-learning. So we will give you we won't give you the materials, but we will give you the directions. Of energy, you still have exams, but for advanced renewable energy engineering, there's only a coursework that you need to submit as your assessment. So it's actually a mixture depending on the course. In terms of these projects can either be individual or it can be in group setting, and we do have links with industries, but usually that is more towards the dissertation. Yeah? So as part of the dissertation, you can also do projects with industry partners. That is on the other side, if you join we have our own clubs and societies within the university. They do engage a lot with the industry. We have career fairs, career days, and then we do site visitations like the pictures that I showed earlier. So these are usually done concurrently. And of course, in most courses as well, we will invite guest speakers from industry to speak.
Okay, sir. I still have one question. Are these courses related to solving numerical problems and these sides of stuff, or just? I'm still a little confused regarding the core subjects of energy.
Yeah, some of them do because it's an engineering program. So of course you have to do numerical calculation. There is engineering at the heart of it.
Okay, thank you so much, sir. You explained a lot. So kind of you. Thank you, sir.
Okay, do you have other questions? Let me see.
Sorry, actually, previously you mentioned that we get a discount if we register early, is it? I didn't catch it.
Sorry, the discounts for, there is an early bird waiver of 4,000 ringgit if you register by 20th of August. And in addition to that, a 1,000 registration waiver as well. So in total, there will be a 5,000 rebate given back to you in your second semester. So you register for the first semester, you pay normal fees. Then second semester, you will get back the 5,000.
This applies for all students, is it?
This is for, yes, for all students.
Okay. Right, thank you.
Okay, any other questions? Okay, I think Asri, hand it back to you.
Okay, thank you, Christine. Thank you, Dr. Adlan, for our session today. So after this, if you have any question and inquiries about our PGT program, either advanced mechanical engineering or renewable energy engineering, you can directly with our education consultant, Christine. I have pinned Christine's email on this chat, and also you can click on the link if you want to chat more about this with our education consultant. So I believe,
sir, before leaving, can you
okay,
sir, sorry for interrupting you, before leaving, can you tell us about the full-time enrollment program? Is it 5 days a week or 7 days a week, like in Malaysia? How is it like can you explain, like the working days,
Dr. Adlan, I think, what is the timetable like for a full time?
You have the 4 courses. Actually, because 2 courses are shared with the part-time, so 2 courses will be done on Saturdays. and the other 2 courses will be done on the weekdays, so it will be spread in 2 days. So I haven't looked at the timetable for September yet, but usually it's on a Tuesday, Thursday, and then Saturday. Yeah, so for the Tuesday and Thursday, it's only 2 hours because you spread the courses 2-hour sessions each, and then for the Saturday, it's a full day. You have 4 hours in the morning, 4 hours in the afternoon.
Okay, sir. Thank you so much.
Okay, all right, thank you. And I believe that's all for today. We are sorry for takes your time this afternoon. And thank you everyone who are joining our PGT preview, Sustainable Energy Transition Toward a Net Zero for the Future. So let's see again next time. I think that's all. Thank you to Dr. Adlan. Thank you to Dr. Christine also. See you